इसका वो क्या काम होता है, क्या कहते हैं उसको?
Ladies and gentlemen, a short announcement. Because of few students came a bit late. If you are not from the School of Computer Applications, you will vacate the auditorium. Because the students from Computer Applications itself are getting their attendance marked by their teachers. So if you are not from School of Computer Applications, make sure you won't get any attendance or any sort of attendance. I repeat, only the students from School of Computer Applications will be getting their attendance marked by their teacher itself. So make sure, and the students who are not from School of Computer Applications, you won't be getting any other sorts of delays or attendance. Thank you.
चलो कोई बात नहीं सर, ओके।
बस मैं रिकॉर्ड पे लाता
We are about to start the formal proceedings. All those who are moving around are requested to please settle down. Stop any cross movement and also.
उनका दस है ना ये फ्लक्चुएशन चल रहा है मेरे मुंडे ने अगे तो अगे मैसेज वो कहना सर तुम पढ़ के डालिया यही था मैं एक एक ये हैशटैग लगाने के लिए कोई गाइडलाइन करना मतलब कि वो मेरे फोन में चला
The dignitaries are about to rise. Kindly please settle down and we'll all rise as they enter the auditorium. We would like to welcome and recognize the presence of our eminent guest, Dr. Radu, Prodan, Professor, Institute of Information Technology, University of Klagenfurt, Austria. Can we have a big round of applause for him? Requesting Dr. Ashok, Coordinator of School of Computer Applications, to please accord a floral welcome to our eminent guest. Journey together with the spirit of curiosity, collaboration. Let's unlock new horizons in the realm of science and technology. We begin with an eye-opening session by none other than my guest of honor, Dr. Radu. He is a professor and distributed science systems of the Institute of Software Technology, University of Klagenfurt. He received his PhD in 2004 from the Vienna University of Technology and was an associate professor till 2018. His research interests include performance optimization, resource management tools for distributed data systems. He participated in various national and European projects. Currently, he is coordinating the Horizon 2020 project ICONIC that researches a decentralized platform and ecosystem for the next generation social media applications. Having authored more than 200 publications, he received 2 IEEE awards for the best papers that he has contributed. The ICONIC, known as the smart social media ecosystem in a blockchain federated environment, it aims to create a decentralized and federated social media ecosystem. And it's supported by underlying blockchain technology. You'll be surprised pleasantly to know that the 3-year project brings together a total of 8 participating institutions and has a budget of about 4.2 million euros. Can I have for him, ladies and gentlemen? Requesting Dr. Radu to please come on stage for his session. Before that, let me request Dr. Ashok to formally say a few words. Dr. Ashok, coordinator of School of Applications.
Very good morning to you all. On behalf of School of Computer Application, lovely professional university, I would like to welcome you all to the second international conference on network, intelligence and computing. ICONIC-2024. I honorably welcome the keynote speaker, Dr. Prodan, Professor, Institute of Information Technology, University of Klagenfurt, Austria. This conference represents the convergence of minds dedicated to pushing the boundaries of innovation in the international domains of network technologies, artificial intelligence, and computing. Today, in digital age, these areas are not only at the forefront of technological advancements, but also even shaping the future of global country. I believe the ICONIC-2024 would be able to achieve its objectives in providing an effective forum of acquisition and researchers to advance knowledge, research and technology for humanity. There is always a gap between peoples and communities who can make effective use of technology and who can't. Now, the matter how much we accomplish and have achieved in research and development, it's not a session in the world of knowledge. Therefore, the focus of this conference is to exchange knowledge. I encourage all the participants to embrace the opportunity to learn, share and connect with fellow professionals and experts in your respective fields. Let's come together to explore new horizons, challenges the status quo, and pave the way for transformative advancements in network, artificial intelligence, and computing. It is hoped that all the participants would apply the ideas and knowledge gained through this conference in managing activities in the areas in order to help community. In conclusion, I extend my warmest wishes to each one of you for a rewarding and enriching experience at the International Conference on Network, Intelligence and Computing. Thank you for your participation and contribution to making this event a milestone in collective journey towards technological advancements. May God bless us all with good health to make this world more beautiful and more enjoyable. Thank you all.
Thank you, President. Welcoming your gathering, we request the keynote speaker to take Dr. Prodan, please come on stage for his eye-opening introductory session. Big round of applause for Dr. Prodan.
Okay. Good morning, everyone. Happy to see you. Thanks for inviting me here. My name is Radu Prodan, University of Klagenfurt in Austria. The introduction was a little talking very nicely about the project that I did in the past, acting on social media. But today I want to talk about something more interesting for me, maybe more boring for you. It's about graph processing. Graph processing, a data structure that sits below social media, and that's a new project I'm coordinating now. It's going on since recently. It's called Graph Massivizer. So first of all, an introduction. I don't know how to interact, but that's the world map. Do you know where is Austria? It's not Australia. Ropar is in Australia, unfortunately not in Austria. Where is Austria? Well, it's there. It's a very small country. We are 8 million, yeah? A street in India, probably. Yeah? 8 million people live in a full country called Austria. And in this country, I'm living in Klagenfurt. So, let me find the laser pointer. Where is the laser pointer? Okay. So the Klagenfurt exactly is in Austria. This is Germany, this is France. Then we move toward East Europe. Austria is here. Klagenfurt is a small city here in the south of Austria. We are at the border with Slovenia, Ljubljana, and well-known Mittal. Yeah? And here is the Adriatic Sea. Yeah? So basically, this is my city where I live. A small city in a small country, but a nice city. So, Auditorium University Klagenfurt was founded in the 70s. So we are kind of proud, you know, we are one of the oldest computer science university in Austria, 70s. Yeah. A new university with the oldest computer science department in Austria. And basically that's our surroundings. You see here we have a beautiful lake. It's very nice in summer to go and have holidays. And this is our campus hosting the university with about 11,000 students. And yeah, the Faculty of Technical Science is also very new since 2007. And you see the green thing, the hills, you know, very pleasant place to stay and do research and cool down in summer and freeze in winter. So the Faculty of Technical Sciences, I'm part of the informatics department. We have mathematics and statistics, we have communication engineering, and from all these departments with 22 groups, about 9 institutes, over 150 members, and also a few thousand staff students. I'm leading a department, a group on distributed systems in an institute that also does multimedia technologies. So it's an information technology institute. So this is my group at the moment. So I have a number of research areas I'm targeting, and I'm also very active in project acquisition. I'm working internationally with many European groups worldwide, also Indian collaborations I have, and I acquired over the past 5 years over 3 billion euro, multiplied by 100, so 300,000 more or less rupees, yeah, to carry out my research. I will talk today a little bit about the graph processing. One of my research activities is a kind of a backend research and development project, so you don't really see nice graphical interfaces from me today. I'm a systems person. I like back screens and doing data analytics on those. But of course, support also the scientists in their visualizations. So let's dive a little bit into the graph processing area. Does any of you know who solved the first graph processing problem in the history? Is there any, who defined first the concept of a graph and do a first algorithm? Well, the guy looked like this. So probably not very modern area, it was pre-Renaissance. I'm telling you the problem before I disclose the name. So it's called the 7 bridges of Königsberg. So Königsberg is currently Kaliningrad. It's the Russian enclave in Europe. It was called Prussia. And basically in the 1736, this guy had a problem. Kaliningrad has 2 mainlands separated by a river. And across the river there are 7 bridges. And the problem, the puzzle, was how to traverse the 7 bridges. So how we can traverse the 7 bridges, but only once. Yeah, so to make sure that we don't traverse every bridge twice. So traverse all the streets of Kaliningrad once only, which translates to traversing as the bottleneck every bridge once only. Yeah. So basically, this person thought about it in mathematical abstractions, defined the concept of a graph. So graph having nodes, 4 nodes here, and 7 edges, which are actually the bridges. Yeah. And the question is, can we traverse this graph, have a walk, but we are allowed to traverse every bridge, every edge, only once, not twice. So, if I'm asking you now this question, do you think it's possible to solve this puzzle? Does anyone have a solution? But you need to shout or come here. No? So how many says no? How many says yes? Say yes. Okay, so more votes, but minority anyway are for no. So basically, it's like this. We had to have a mathematical rational and algorithm. So in order to traverse a bridge, you have to enter every node once and exit it. Yes, you have to enter and exit, enter and exit. It means you need to have an even number of edges that connect to a node. Yeah? Except the start and the end. The start you can exit once, the end you can enter once. All the other bridges, all the other nodes, sorry, you have to enter and exit through one bridge. It means, except two nodes that you are choosing, all the other nodes must have an even number of edges connecting to it, which we call the degree. Now, if you count here, it's 3, it's 1, 2, 3, 4, 5, it's 3. It's also 3. Yeah? It means it is impossible. Yeah? So the no people who are right, it is impossible to traverse this graph by traversing every edge, every bridge only once. This guy is called Leonard Euler, one of the most famous mathematicians worldwide. And basically he used basically his brain to solve this problem in an analytical way. If you want to traverse, so to enter one node and finish in the same node, the path would be called the Eulerian cycle, which basically requires that every node has an even degree. So basically this was done in the 1736, and it was a hard time, for science, for mathematics. We didn't have computers, so there was no, Dijkstra algorithm to compute the shortest path in the graph. To solve such problems, you have to use the brain, and the graphs were small. Well, then it continued the development. Graph theory basically found use in other sciences. For example, this guy, I don't know if you know him, but it's Kirchhoff. Basically, he defined 100 years after, so it took 100 years to define the fundamental law of modern electrical circuits and engineering, combining graph theory with computational techniques. So progress was hard. Where are we now today? So graphs are everywhere, not only on social media, but social media is a good example. We are connecting with each other, we are friends, we can represent the entire Facebook infrastructure as a graph. The graph, of course, is not that big with 7 nodes. It has billions of nodes. There are billions of users worldwide using social media. They are all connected with each other. How do we manage such an infrastructure? How do we develop algorithms? How do we scale in real time so we simply get useful information out of it in useful time? Basically, that's what is going on. Social gaming networks, gaming, one of the biggest trending industry, attracting millions of users. We have billions of that. This is 100 billions of connections. The internet, the web, that's also a graph. We have web pages and we have links. In between we have lots of connections, so we can also represent them as a graph. 50 billion pages, 1 trillion of hyperlinks. Holy grail is the human brain. Holy brain, we have neurons, we have synapses. Probably the largest graph in the world that we still don't know how to represent. We research it. 100 billion euros, 100 trillions of connections. Of course, Euler did the first algorithm with his brain, his own brain. It was like the human intelligence. For these massive graphs, we need artificial intelligence. The human intelligence simply cannot scale to these dimensions. But still, we can develop artificial intelligence algorithm basically to tackle such problems. So this is the kind of the new research I got fascinated about. We want to basically develop a holistic platform that enables the processing of such massive graphs that exist everywhere nowadays. All our data, all the information, entity relationships are in the form of graphs. So this is the project Graph Massivizer. We call it. It comes from Massive Graphs. It's a Horizon Europe project, so that's kind of the flagship research and innovation program in European Union. It connects basically all the European countries, and by the way, there are also specific programs targeted also with India. In Erasmus, for example, plus there are some calls, so maybe we can look into the future and also connect together as part of such a research program. So the Graph Massivizer project stands for Towards Extreme and Sustainable Graph Processes for Urgent Societal Challenges in Europe. It's a 5 million euro project, so about multiplied by 80 or 90 rupees. And we started in 2023, so we are kind of approaching the middle of the project, but that's a difficult phase when we kind of started understanding with all the partners what we want to do in these projects, and now we are moving towards results. And we are 11 partners. We are about 5 universities, 5 companies, and 1 research center, supercomputing center, developing the 5th supercomputer, fastest supercomputer in Europe, 3 Texas series supercomputer. So the goal of the project is basically to develop a high performance and sustainable graph processing platform for handling extreme data. So what we mean by extreme data? Extreme data is data that's larger than big data. You know, we talk about big data, everything is data nowadays, we produce more and more data. Extreme data basically goes orders of magnitude in terms of its speed, properties like velocity, volume, and so on. So the data that also in complexity, yeah, that represents a big, the massive graph basically has this exponential complexity in volume and relationships. And we want to develop a holistic platform that we target the 3 sustainability pillars. So we have economic value, so we will talk about some use cases that basically have graphs as the underlying data structure and they want to generate economic value out of it. For the society, of course, economy is not good if it harms the society, so it has to bring some benefits to people. Yeah? So not only the rich people should benefit, but regular people. And of course, the society is also not sufficient if you harm the environment. Yeah? So we as a society should behave in an environment-friendly way. Yeah? We talk about climate change and other negative impact that the human society has on the environment and on the earth. So basically, the environment surrounds society, which surrounds economy. These are the sustainability level that will guarantee success, yeah, to our research and development. And the graphs basically are the data that we are generating and the data that we need to conduct analytics on to capture, combine, and process knowledge about real and the digital worlds. So my project, basically, this is the picture for the beginners, like the introduction to the project. We use at the center the concept of massive graph. So these are huge graphs at the representation of extreme data, integrating patterns, storing, interlinked description, objects, events, situation, concepts, and semantics. So by graphs, we mean general graphs, so mathematical abstractions. In the semantic web technology, there is a concept of knowledge graph, yeah, in the rich data format representation, so represent conceptual relationships between entities, or property graphs, basically graphs that are linked to specific labeled relationships among entities. And we would like to target here an extreme data challenge. Basically, extreme data challenge means extending state-of-the-art existing technology in at least 3 or more of these key characteristics. I think you heard that. Volume, for example, supporting up to billions of vertices and trillions of edges. So we want to scale the processes to really huge dimensions by order of magnitude. Velocity, data is not static, data is flowing, data is streaming. People, stream videos all the time, so we want to handle this diversity and dynamicity of data by even changing graph topologies. And we invented our own V. Yeah, this is kind of my hit on this V challenging graph processes. We call it viridescence. In English, it means greenish. Yeah? So we want to have green data processing. So green computing is something we also want to target. So how to do it at an environmental friendly way. And we want to build a platform consisting of 5 tools, integrated tools that support different phases, different stages in the graph processing pipeline. We start with data ingestion and graph creation. So you have streams of data being generated on the fly all the time. You want to create these graph structures in real time, online, and also persist them in a scalable way. Once you have the graphs, you want to do analytics and reasoning. Yeah? Here we apply machine learning, probabilistic reasoning, approximate reasoning techniques, because the data that we have in real world is noisy. Yeah, people don't generate really accurate data, and for these reasons, basically, you need to have some sort of noise and fault tolerant techniques. And these 3 tools, basically, these are the operational part, and the following 3 tools are the processing part, basically where we are sitting in my view. So for the graph modeling part, basically we try to model hardware. Existing hardware is not good for graph processing. It's dense hardware and it's good for dense problems, like linear algebra problems, where you have matrices and you have good locality among different elements on the data structure. Graphs are irregular, graphs are random, graphs are chaotic. They are dense graphs, they are sparse graphs, interconnections, they have different topologies. Graph algorithms are hard to write. Yeah. You have a JSON matrix, but you don't really traverse in a very regular way that data structure. So we need here graph workload modeling, trying to understand the hardware, trying to understand the workloads, trying to have some predictive information. We want to do it in a small scale here, but we want, through simulation, to understand the global impact of such algorithm. And here we have energy awareness and sustainability aspects. Yeah? Understand how much energy you consume of these graphs and how does it impact in quantity of greenhouse gas emissions, for example, the environment. And this is my tool, scalable serverless graph processing. And here, basically, it's an enactment of the graph analytics. So whatever we reason here, we build the hardware here, and here we have to basically run it, operate, yeah, execute it on an existing infrastructure. And this is my tool using the serverless technology. Probably you know Amazon Lambda. Yeah. It's basically an event processing platform that is really suitable for operating such urgent, extreme responsive applications. So this is the toolkit. Basically, again, we have 2 layers: operational layer in the front and processing layer in the back. Now, in the operational layer, we again have a tool graph inceptor, so we can create graphs by ingesting extreme data, creating such graphs, and persisting it, yeah, on the fly into a storage platform. The graph scrutinizer tool develops analytics and reasoning. So here sits Euler with his algorithm, yeah, but now we don't use simple algorithms, but we rely on more complex machine learning and probabilistic algorithms. On the processing layer, again, we have the optimizer tool. So this is the hardware tool, will be to work with modeling, with performance and energy guarantees. So you try to understand what your algorithm requires in terms of hardware and what is the response time and the energy consumption of each workload that you are doing. The greenifier tool basically scales the optimizer at the global scale, trying to understand, okay, on the small, this is what will behave, what happens if you deploy it on the internet in a bigger environment. This is something you cannot understand unless you do it, but then it may be too late, so you want to do it first through simulation, try to see how does it scale your problem, what is the trend. And the choreographer, my tool, basically does scalable massive graph analytics over this computing continuum. Yeah? The computing continuum basically is the everything that we see now in the digital computations field, from high performance data center to really lightweight mobile edge devices. Yeah? We have a full range of devices, and of course, computing always in an expensive data center is not environmentally friendly. They burn out a lot of electricity. Sometimes it's useful not to overload the network to the data center, but really stay light on your edge device. And this is what this choreographer tool is. So we also have a company, Meta Factory in Europe, that is planning to basically market this pipeline once we have it completed by the end of the project, hopefully. So we also plan to have an economic impact with our platform. So let me now introduce each tool step by step. So basically on the graph creation side, we want to build extract, transform, load procedures. So we become a little bit more technical now to persist this extreme data into massive graph with 10 billion of vertices and 100 billion of edges. So this is kind of the, we also have targets here in terms of size that we want to achieve. We want to have batch and stream data processing. We want to be compatible with existing platforms, so we built on BARTIK100. Sure you heard of it. And we want to have an ingestion latency, below 500 milliseconds for a large part, 95% of the data at a certain throughput, thousands of pages per second. So we really have technical requirements how we want to process these incoming streams of data and to generate the graphs as they stream in. And in terms of graph storage, we mostly target knowledge graphs that are represented in this RDF, resource description format, modeling semantic aspects, property also, model with edge properties, and unifying the two view with the RDF star graphs. And data, of course, at these levels is not always centralized. We also have to have a distributed repository, so graphs that are kind of distributed in the storage on the computing continuum. And a partner from Norway called Sintef is a research center. It's responsible for this tool in the project. Now the scrutinizer tool, it's an institute in Slovenia. It's our neighbor in the south of Klagenfurt, less than 100 kilometers away. They do the graph analytics, so they are specialized in AI. They also do a lot of artificial intelligence, large language model research. But in these projects, basically, they do the analytics, and they want to support, the ingestions through analytics that have the same scalability. Like when you do the analytics on the incoming graphs, you want to discover the topology, you want to have a large number of edges that are processed per second, and also streaming graph resonance of a few million triples per second following existing tools like the Apache GraphX, Python Geometrical. So they are graph processing tools, specialized libraries, and AI tools. Of course, we have heard about Python that basically can be used in targeting this analytics part. And you want to, again, be performance, so by scaling you don't want to be slower, so you want to retain the performance always for the last 10 million edges compared to existing non-online, non-real-time algorithms, like the batch algorithms. Now how do you do it? That's hard, Always operating on a full graph with so many nodes will not scale. Graph algorithms are typically quadratic, even more complex. So we have to rely on some approximation techniques. And one approximation technique is sampling. So sampling means if you have a graph, you want to sample it in a way that you get a much smaller graph out of it, but it's a kind of a small copy of the graph, a miniature of the graph. Yeah? If you preserve the property, you preserve, for example, the clustering coefficient of nodes, betweenness centrality. So basically the topological network must still be preserved. You can reason on the smaller graph, but then still be confident that your reasoning will apply on the larger graph as well. Yeah? This is called sampling. And this sampling should be done also in memory, yeah? to have fast outputs on your reasoning algorithm. So always reasoning on the hard disk, on the storage, it's also of course not very expensive. And another thing is graph enrichment with expanding data sets. So data is incomplete, yeah, always incomplete, always arriving new data, and also companies struggle to keep this information always accurate. So with graph enrichment, basically we try to always get more information from the data that we have, also for the incoming, for the expanding data set, and all have an enriched information of the graph that is suitable for further reasoning. We want to use graph discovery, low footprint graph generation, and real-time error bounding queries, combining these two things.
Thank you.
We also use graph summarization. So graph summarization is similar to graph sampling, but you don't sample the graph randomly. Instead, you simply try to discover properties of the graph and then generate the graph that is a summary of the big graph. Yeah? So these kind of things are part of the study. How to do analytics on a massive huge graph stored in a distributed way, but very fast. Now, this is the analytics part. With the optimizer, basically, we go on the hardware. Yeah? Hardware means you want to see what hardware is used for operating basic graph operations. And basically in here we try to model energy and performance costs using CPUs, GPUs, FPGA, accelerators, and modeling things like memory latency, bandwidth, throughput in graph operations, I/O, and so on. We model basic graph operation as composition of hardware operation, and here we use other libraries like Graph Plus, GPT, CUDA, so we also graph. It has been done since a long time, so we want to make use of existing results, and at the same time explore further how would this behave graph algorithms. So we want to generate workflow models using the design space exploration, and the outcome should be some sort of a predictive model. If I have this graph, if I have this machine, if I have this workflow coming, how would it behave? I need to know, because when you go into operation, you want to be sure that it performs well. Yeah? So here we want aim for an accurate performance and energy trade-off. So doing fast but consuming energy, or doing slow or saving energy. It's a trade-off. Yeah. Sometimes you want fast and expensive, sometimes you want slow and cheap. And here we want to use very heterogeneous processor GPUs and FPGA. So University of Twente in Holland Netherlands is handling this optimizer. So small hardware for graph operation. And their friends from the Vrije Universiteit, so Free University in Amsterdam, basically they expand on this idea and they want to build a greenifier, a greening tool for graph processes. So how would this behave at scale? So in this case, basically you cannot do it but through simulation. Yeah, so they simulate data center, they collect data that is coming from various energy providers, including green energy, and they try to understand how to operate these workflows in an environmentally friendly way. Yeah. So ideally would be zero greenhouse gas emission. Yeah. So they collect sustainability data from operating infrastructures, in our case their own, but they also have connections to power grids. Yeah. and basically they have open market data that they use also to understand how expensive is the energy, how would my workflow behave if I inject data from certain grid, power grid operator. And basically they have a work-driven graph processing simulation toolchain for OpenDC that they are developing, and they simulate carbon footprint, CO2, methane emissions, and so on. They use some benchmarking, they use the prediction from the previous tool, from the optimizer, and they want to make a recommendation for performance and sustainability trade-off. What we target for is some sustainability labeling, like from your appliances at home. If I buy a fridge, it's labeled A+, it means it's likely that I will pay less energy in time. Or if it's labeled B, C, D, it would be more energy consuming. So this kind of sustainability labeling we want to do for graph processing. How expensive is this algorithm in terms of energy? What is its label? And we also have some targets with respect to improvements in data center energy efficiency and greenhouse gas emissions. So we always set some sort of a target to have some expectations and some challenge that we want to achieve rather than having it open. So the greenifier, it's trying to understand this at a global scale. And finally comes my tool. This is the choreographer. This tool basically takes the whole graph processing workflows that we have and executes them. So it's really the tool that makes things happen. We use the workload infrastructure code design that takes place in the previous tools. We have a multi-layer infrastructure facilitation, so we want to use different cloud, edge computing devices federated across the different institutions, the different partners of the projects. And we use different technologies, OpenWhisk, this is the open source serverless technology, or we can use Lambda from Amazon, so it depends if you want to do it open source on your infrastructure or do it, in a commercial one. And we compare with other commercial tools like Aligraph. This is the Chinese competition, coming from China, using they're building a toolkit for graph processing on their side. And we also compare with energy for ETL storage over Amazon S Redshift and other open source solutions. Security is also part of this tool, but we are not a security group, so we don't want to invest time in setting novel security things, so we simply apply state-of-the-art security and privacy mechanism. What we want to improve here through our technology is the runtime deployment. So copying, deploying, your infrastructure to a different site can be very expensive, especially if you talk about graph processing. So moving data, caching data, deploying serverless function, has to happen somehow proactively in real time, and this is part of the cybersecurity stuff that we are also doing. Okay, so it's a complex tool. Graph creation, graph analytics, hardware construction, sustainability simulation, plus orchestration, so execution. But we also have use cases. Some industrial partners are also part of the project that basically are trying to use our toolkit for their own business. And we have 4 use cases. They are coming from green and sustainable finance. So basically a financial company that is interested in green bonds and products. We have a tool basically on global foresight for environmental protection, so basically try to influence policymakers in discovering and enforcing certain trends on the market and society. Green AI for automotive industry, so we have an industrial partner here that is producing body-in-white car tools, and they are using AI to automate the pipeline. And my favorite data center digital twin. So basically we know supercomputing today moves exascale, so 1 billion operations per second, so huge computing power. They are not sustainable. Yeah? They basically consume a lot of energy. We want to build a digital twin that is kind of trying to have a sustainability metric behind this design. And you see in terms of the characteristic of big data, we have a lot of variety. So we try to target the use cases with a volume, with a big velocity in data flowing. Data value is also a big thing, you know how much value has your data, and others. So just check my time. Oh, so we are nearly close. Okay, so let me cover the use cases now quickly. So for the green and sustainable finance, basically the company is called BARTIK100, is from Ireland. Basically they are interested in financial products, investment services that channel them into green focused company. Green bonds are very popular today, green lending, green equity investment. The problem that they have is that algorithms in finance are very hard to develop. Yeah? They operate on graphs. Yeah? So financial data basically has a graph structure, but it's limited in availability. It has reduced accessibility and it's very expensive. So building algorithm for financial products is very, very hard to understand where to invest, yeah, in the future. And basically what we do here is we generate synthetic data. So we use generative AI, yeah, similar to ChatGPT, but we don't use it for language generation, but we use it for graph generation. So this is kind of the opposite of sampling. We have a limited data, and you want to expand this data to a huge graph, but it's still synthetic, but you hope that this synthetic graph will match the real graph, to which you don't have access, because it's expensive. Yeah? The financial domain is unfortunately dominated by big companies. You know, they don't disclose their data, and we have this BARTIK100. This is a small company. They try to enter the market, but of course they have to offer their disruptive technology instead. So they offer cheap data, yeah, that is generated synthetically through our project, rather than expensive data which is not disclosed by the big companies. So we want to have this called synthetic financial data multiverse for semi-automatic creation of realistic and affordable synthetic stream financial data sets, unlimited in size and accessibility, which should offer basically improve and optimize green investments and trading. Yeah? So we want to offer a convenient, affordable solution. Yeah? The other use case, basically a company called Event Registry in Slovenia. It's global foresight for environmental protection. Basically, they target geopolitical and business aspects of United Nations Sustainable Environmental Goal. So basically, they deal with climate actions, responsible production and consumption, green water and sanitation, clean and affordable energy. Basically, they crawl on social media, they analyze existing trends that are happening worldwide, and they want to give foresights on future trend scenarios, guiding better policies that are limited currently to expert surveys only. So these analytics are done manually nowadays, and we want to have them doing automatically. And of course, crawling web, crawling the internet basically generates huge social media graphs. So we have a massive graph encoding, common crawl, link open data cloud, linear views, and so on. And we have two types of analysis: horizontal scanning, identifying threats, risks, issues, and opportunities, and mega trend analysis, exploring relations of massive graph structure to shifts in behavior. Yeah. So we want to understand basically trends happening in the society here relating to these aspects of the United States. Kind of a closed use case here comes from Bosch. I think you heard from Bosch. It's this big German company. They often do fridges and all sorts of home appliances, but that's not their main their main focus is on automotive industry, so car, body and white products. Basically, they have a value chain involving heterogeneous, distributed, fast-growing, and incompatible extreme data, so they struggle with their big data workloads, and they focus on welding, production, robots, car, body, and whites, as I said. So they work for automotive industry, you know, building such car components. And we have a green manufacturing line diagnosis pipeline here. We use basic graph integrating such collection of digital twins. We use ontologies here to describe the data. And we use green machine learning methods for massive graph alignment, summarization, search, pattern matching, quality assurance, and so on. So we want to predict welding spots quality produced by their robots, by their welding machines to devise their configuration, remote diagnosis, repair schedule, accessory replacements, and so on. Yeah, so it's a very, very complex pipeline that they are using, and they have knowledge graphs, massive knowledge graph underneath to automate it. And the last use case, and probably my last slide for today, basically is this data center digital twin for supercomputing. So HPC, high performance computing, has limitations, throughput limitations. Basically, the simulations are never, the computers are never sufficient for running high performance simulations, and they require larger and larger machines. But of course, setting up these machines consume a lot of megawatt power of electricity. So operating this supercomputing is a challenge. And basically, we want to increase the science throughput, so we want to have supercomputers that have faster delivery of scientific results, but also with a lower greenhouse gas emission. So what we are doing here is trying to do a data center digital twin. It's represented as a massive graph, so computers, you know, have millions of nodes, billions of cores, nowadays, so you can have a supercomputer represented as a graph with billions of nodes representing the cores, and the edges between the cores are basically the connections, the computer, the bus, and so on. You have cooling systems behind, you know, you have to cool such systems down to be sustainable, so it's really hard to model the entire operation. And basically, we have to have a graph that is capturing exactly the semantic temporal relationship between monitoring metrics, nodes, cooling equipment, and so on. And what we are doing nowadays is we apply graph neural networks to understand anomalies. So these computers basically fail a lot. If you have billions of cores, it's very likely that you will have regular failures. How does your application cope with these failures? It would be good if you can predict them, So basically we apply graph neural networks trying to understand the neighborhood, the relationship between the nodes, the metrics that are connecting, and trying to predict anomalies in the future. Predicting anomalies is hard. It's hard because anomalies are rare, and you are very accurate if you say an anomaly will not happen. Very accurate, 99% accurate, of course, it's an anomaly. So how can you predict anomalies in an accurate way? So rare events, to predict, but still to be accurate. So if you want to have a metric that quantifies this is a very hard thing. So anomaly prediction is something that we do. And basically, I think I conclude my talk. I also had a technical, more algorithmic part showing in more details one of the algorithms that we are doing in this project. But I think time is running out, so we can take some questions. Thank you very much.
Very niche and intriguing area of research. I'm sure you have lots of questions. Dr. Prodan, can you step forward for answering the queries? In the meantime, we can switch off the screen and carry on our proceedings. If you have any questions to ask such an intriguing and niche area of research, I'm sure all the ardent learners and researchers here would be having a few questions to be asked to the subject matter expert. Can you pass on the mic also, please?
Yes.
Good morning, sir. Sir, like my question is like we are working with synthetic graphs, we are generating graphs with simulations, like most of the graph problems we are doing using synthetic graph simulations we are getting graphs. So the algorithms we are proposing on synthetic graphs, can we generalize those algorithms for the real world graphs? Like real world graphs are not really most of the time. So can we have a technique to generalize our data which we have produced on synthetic graphs on the real world graphs, like the accuracy will not drop down?
Yeah, it's a very hard question. We have the same problem. Yeah, I think we should take the opposite approach. Like, you know, we have to start somehow from the real world graph and then from those generate synthetic graph. Yeah, synthetic graph are nice if you somehow try to, you know, validate some of the non-functional properties maybe of the graph algorithm. So, you know, you have scalability, you have, you know, some, you know, graph properties like density and so on. So these things, you know, your algorithm would work well. But yes, trying to project a synthetic graph algorithm and on a real one in terms of accuracy, you know, this is something very hard. Yeah. So you have to take the opposite way. Yeah. Have the real world data, trying to understand the properties, and then to tune your synthetic graph or take the alternative synthetic graph that you have, which matches the real world one. Yeah. Going blindly from synthetic to real, basically, it's hard, and you know it drops your actual accuracy anyway.
Thanks.
So lots of ardent researchers are sitting here, including our faculty. So you're already, it's an open forum. Any one of us can ask a question pertaining to the expertise that the eminent guest has shared with us.
Hi, sir.
Hello.
Sir, you have discussed about your serverless technology, your graph sustainability, like Lambda. So can you please assist on what sort of events you are handling in Lambda for the sustainability of the graph?
So the events that we are handling, basically, we are doing graph processing in real time. Yeah. So basically, it's a sort of a dynamic graph. Yeah, with the data coming, we construct the graph on the fly. So basically, it's these events. You know, the node construction, the edge construction. You know, at different moments in time, basically, we get a new event. Yeah. So basically, this is what we are using, you know, to trigger a different graph processing steps. Yeah.
So whenever a new node is coming to the graph, the event occurs on the Lambda and
Yeah.
notifies it to the...
Yeah, yeah.
I think this side, right in front, there will be a few questions and queries of users, or information also. You can seek information also.
Ladies and gentlemen, if you are having any questions, please raise your hand. I will come with the mic. Do we have any questions?
Hello, sir.
Hello, Mani.
Sir, you talked about it in your algorithm. You talked about a process like sampling, where you are like collecting a sample of like massive extreme data, and you are calculating all your analytics and reasoning on that. You're applying your algorithm on that sample, and it is being the technique is being applicable to all. So my question is that how much can you rely upon the accuracy based on the sample? Like, is the sample like 100%? Like you can like the technique applied on that is 100% applicable to the real world extreme data?
Yeah, of course, it's not 100%. We call it probabilistic. Yeah, so it's a probabilistic method. Yes, so we kind of do a trade-off between the performance of your method and the accuracy. Yeah. So of course the question is how big the sample should be. You know, the bigger it is, the more accurate it is. So we have we are building now a tool basically that try to make some accuracy prediction. Yeah. So we are using AI, trying to understand how different sampling algorithm basically actually reflect the real graph. Yeah. So, but your question is definitely, yeah, correct. 100% you cannot, yeah. Magic is not possible, so you have to have some trade-off.
So like when we're like considering that part, so like how much impact does it have on like social media platforms?
I don't have a question answer on that. We don't have a social media use case here. But social networks are kind of scale-free networks. Yeah. So basically, you have this sort of influencers in the middle, the super hubs, and then you have the peers around them. So basically, if you want to model a social media, you have to make sure that it's a scale-free network. They have this power law. Yeah. Very small diameter. Yeah, and very high local connectivity. So if you build such a Alpel Barabasi, for example, is a typical example network. The topology of the social network is not so challenging. It has been studied since a long time, and I think we know quite well how to model that. Yeah, they are scale-free networks which don't have a structure, but they have well-defined structural properties. Yeah, so I expect social media to have a quite accurate modeling, and I'm sure companies like Facebook do it quite well.
At this point of time, I would like to welcome and recognize the presence of Pro Vice Chancellor, lovely Professional University, Dr. Laviraj Gupta. Request Dr. Ashok to please accord a floral welcome to our dignitary. Dr. Laviraj Gupta himself is a role model for many of us. He's a leading light in the field of technical and higher education. And himself very research focused. He's had great credits to his already accomplished career. And I would deem it my privilege to request Dr. Laviraj sir to please say a few words of wisdom to this august delegates of International Conference on ICONIC-2024. Can we have a big round of applause for Dr. Laviraj Gupta? A very accomplished researcher personally. He has almost 230 plus patents filed, out of which 204 have been published and 30 plus granted. A big round of applause for Pro Vice Chancellor, Dr. Laviraj Gupta sir.
Thank you, Mr. Patra. Good afternoon, everybody. Rather good noon. Tell me how excited you are after listening to Dr. Radu. Tell me how excited. You know, an individual of his caliber might have instigated you towards new developments in information technology. Because I've been told that he interacted with you on graphs. He primarily talked about extreme data. And we generally are into the foray of big data. We all understand that big data revolves around 5 V's. You all know about them. It's about volume, variety, veracity, and so on and so forth. But he has defined a new V on the extreme data. That is varied essence. The moment I was told about this extreme data, I went back to my notes and started studying about it. And this V surpasses and surmounts all the other V's. Because in today's world, it is not about computational capabilities and capacities of the machines. We need to look into the power consumption, the resource utilization, and more so ever, effective, efficient functioning of computational machines. That is where the V of Viridance came into picture. I must propose a loud round of applause for Dr. Radu. The School of Computer Applications, please keep quiet. Volunteers, please keep quiet, you too. I must appreciate and take cognizance of School of Computer Application under the headship of Dr. Ashok Kumar and his learned faculty members, that they have chosen the second edition of ICONIC-2024 to be BARTIK100, celebrating the centenary birth year of Miss Bartik. She was one of the 6 people who started working on ENIACs. Believe me, when I started computing way back in 1987-88, ENIAC was something, which used to keep it as model, its photograph as a model, because see, from a computer which is bigger than the size of the stage, now it has boiled down to this particular thing. You must appreciate the technologists, you must appreciate the efforts of the scientists, that how minusculely they have created wonders. I was going through the profile of Miss Bartik. I really do not know if you know about Drupal. Drupal has come up with 10.2 version. It's a content management system, CMS. And they have taken Bartik's postulates and they have grown substantially and exponentially. I'm talking about this conference. The basic intent, the basic premise of conferences like these should enlighten you, should edify you on the challenges which are ahead of us. With the advent of large language models, large vision models, transformers coming into picture, and weights of the nodes or weights getting taken over by the attention maps, has really proven worthy for the ease in computing and for availability of data. But then there are challenges. There are 2 model-specific challenges which I am going to talk about. The very first model-based challenge which the entire world is facing right now is catastrophic forgetting. I'll give you your example. If you see a friend walking towards you, suddenly it happens with you that you forget his or her name. It is very much there on your tongue, but you are unable to recite that name. Similarly, now the models are doing so. The misbehavior, I'll call it as misbehavior of Zenith and ChatGPT, is one of the outcomes of catastrophic forgetting. We, all of you sitting in this hall, should look to not extracting your logics out of ChatGPT or Gemini, but you need to understand that where they are going wrong. You might have never read a report that how Gemini went away from the mainstream. You might have never read, because that is where your career remains. Your career does not depend on the present performance of Gemini. It depends on the present performance vis-a-vis the challenges with models like Llama, like Bloom, like whatsoever name you give, Pika or Sora would have, maybe after 1 year, 2 years down the line. The second major problem with the models is hallucination. They're getting hallucinated, meaning thereby if you show them 10,000 images of dogs, and after that 10,000 image of dog, you show the model an image of cat, it will actually get hallucinated and return back. Dog as an answer. Isn't it your imperative? Isn't it your prerogative that you start thinking on those directions? Otherwise, you will be the users of generative AI and would not score above than the users. The biggest challenge which I've been reading past week, the biggest challenge is standardization, norms and regulations for these generative AI models. There is no testing model available, there is no standardized parametric model available which can standardize. Right now ChatGPT says that we are more effective than the other models. Is there a gauge? Is there a measure by which you can say that whatsoever is being said is true? You know, in 1950 somebody thought of creating a testing model. You all know his name. That was the Turing's model. In 1950, that was the first testing model which was given. There's a humongous gap between 1950 and 2020. In 2020, somebody came up with MMLU, Massive Multitask Language Understanding. But still, the parameters are not defined. People are nowadays talking about something called as truthful QA or Hella swag. But these are not the models which are generalizable. These are specifically for certain acts and activities of the large language models which they perform. But do you have a measure? Do you have a ranking mechanism? Do you have accreditation mechanism of these models? Believe me, if in conferences like this you delve on challenges like this, then only you are towards your career. Otherwise, you'll be coders, wonderful coders sitting and working for somebody else. You know, ChatGPT is an output or an outcome of just one research paper which was published in 2017, and the name of the paper is Attention is All You Need. Out of 7 of those researchers, 4 of them were Indians. But then, who took the advantage of that research paper? Is Altman. Created an open AI kind of thing. But you are the ones who can take up those researchers and create platforms like GPT. If you are not willing to do so, then start understanding the parameters on which you can judge, gauge and measure the performance of generative AI models. Even if you can come up with 10 such parameters and standardize those parameters, your company would be a better company than OpenAI or Meta or whatsoever it is in your mind. I request and I beseech the organizers of this conference that there has to be a session, an open house with the students. Let them go and search what kind of challenges tomorrow, next year and in next decade the technology of today is going to face. And let us talk about the solutions, the preemptive, the primordial solutions to those challenges. I once again thank Professor Radu to be with us, and I wish this conference to be a grand success. Thank you.
Thank you, sir, for sharing the future roadmap for our computing students in the event of generative AI, challenges that they foresee and the role that they have to develop accordingly and align themselves with the future ready. Ladies and gentlemen, we are just about to be joined by a worthy Pro-Chancellor.
him an accomplished personality who embodies commitment, compassion and competency. We welcome our worthy Pro-Chancellor, Mrs. Mittal. And I request you, ma'am, please grace the stage along with the other dignitaries for the next proceedings. Requesting worthy Pro-Chancellor, ma'am, to please step on stage. Requesting all the dignitaries to please accompany Dr. Radu, Raviraj sir, Dr. Ashok, remarkable personality known for her unwavering dedication and exceptional leadership. Once again, let's have a big round of applause for our worthy Pro-Chancellor, Mrs. Radu. And I request Dr. Raviraj to please accord a floral welcome to our chief guest of the conference. Dignitaries to please step up in front for the auspicious lamp lighting ceremony. Conference has been very encouraging. Lots of abstracts have been received and they've been compiled into an abstract book. So now it's the time to unveil the abstract book. And once again, requesting the dignitaries to please step in front for this abstract release ceremony. The release of the abstract book as an outcome of the encouraging response by our ardent researchers. Requesting the heads of the departments and the coordinators, please step on stage for release of the abstract book.
contribute a token of love and gratitude on behalf of the LPU family to our guest and eminent speaker of the day, Dr. Radu, requesting worthy Pro-Chancellor Ma'am to please do the honors of felicitating Dr. Radu. I would like to request the head of the School of Computer Applications, Dr. Ashok, to propose a formal vote of thanks. And in the inaugural session and embarking on the technical session of this beautifully crafted international conference, ICONIC-2024.
Worthy Pro Vice Chancellor and Presiding Officer, Madam Mittal, respected Pro Vice Chancellor and Head of Faculty, Dr. Gupta, Dr. Radu Prodan, my dear colleagues present over here, participants and dear students. Very good noon to you all. It gives me immense pleasure to extend a heartfelt word of thanks to all of you who have graced this inaugural ceremony of International Conference on Network, Intelligence and Computing with your esteemed presence. First and foremost, we are indebted to Honorable Chancellor and Member of Parliament, Dr. Mittal, Pro Vice Chancellor and Presiding Officer, Ma'am Mittal, for giving us this opportunity to organize such a mega event. We bow our hat in gratitude to both of them, although sir is not present, for putting faith in us. Thank you very much, ma'am. My words are not capable of communicating our sense of gratitude to Pro Vice Chancellor and Head of Faculty, Dr. Gupta, for his guidance, suggestions and support in organizing this event. Thank you, sir, for your guidance from time to time. We convey gratitude and heartfelt thanks to Dr. Radu Prodan, Professor, Institute of Information Technology, University of Klagenfurt, Austria, for very kindly accepting our invitation to grace this event with his presence. The valuable thoughts that he has shared with us will no doubt serve us in good steps. Thank you, sir, for your gracious presence among us today. I thank all the participants who come from different parts of the country to share their valuable insights on various issues and challenges. I shall be failing my duty if I don't thank each and every one of you who has worked round the clock for the last couple of weeks to organize this event. Once again, I thank Pro-Chancellor Ma'am, Dr. Rashmi Mittal, Dr. Laviraj Gupta, and Dr. Radu Prodan. Thank you very much.
Thank you, sir. The last item on agenda is a group photograph of the organizing committee with the dignitaries on stage. So kindly hurry up before we begin the technical sessions. A photograph of remembrance of all the hard-working committee with the honored dignitaries. As we are about to embark on this remarkable journey, it's time to ignite the quest for knowledge, forging new bonds, transcending all the boundaries, connecting as a global community of thinkers and doers, willingness to collaborate, innovate, and push the boundaries. Thank you, ma'am. Thank you all the other attendees on stage. So the students are requested to please keep on sitting as the worthy guests leave the auditorium and we begin the technical sessions. So now, the quest for knowledge and journey starts. So, river delegates, enjoy the technical sessions in the conference, build your network, and thrive and evolve as the time evolves. With this, we come to the end of the inaugural session and beginning the technical session. Thank you.